All right, so we're going to work on understanding the idea of compound inequalities. And our question is, how can you use inequalities to describe the sets of numbers graphed below? So we have this number line for part A. I can see there are two circles on the graph. So I know this represents an inequality, that represents an inequality. We've got a closed circle at -3 and everything shaded to the left. We have an open circle at +2 and everything shaded to the right. So what are the solutions to this inequality right here? Well, it's going to be any x values that are less than or equal to -3. So that's all of these numbers less than or equal to 3. Or it could be any numbers over on that side. So we're going to say, or maybe solutions for x could be, I'm going to say greater than, because of the open circle, greater than a +2. So this is what an or inequality looks like. You got your two circles, open or closed, and they're shading in opposite directions. You get one inequality to represent one part of the graph and the other inequality to represent the other part. Okay, now if you compare that to part B, you can see this looks different. We have our two circles, so I know there's something happening with a -4 and a +1, but this time all the solutions are everything between those. So what this will look like, we can write it a couple ways. I'll show you the first way. This first inequality right here, -4 is a solution, and the number's bigger than -4. So we'll say, all right, so x can be greater than or equal to -4. And then because these other solutions are heading the same way, right in between, and all your x's can be less than that +1. So you could write it this way as two separate statements, x is greater than or equal to -4 and x is less than 1. If you notice these shaded regions, it is greater than -4 and it's less than 1 at the same time. So that's why we're using the word and. It's not one or the other, it is both inequalities. Another way that you'll see that written is you have your -4 and if you notice, see how -4, how the small end is pointing to the -4? That makes -4 the smaller value. So -4 is less than or equal to x. And then over here, we know that x is less than 1, so we're just going to combine that and say is less than 1. So here's your and inequality that can be combined. Your or will always stay separate, two separate ones, but your and can go together. If you notice, the x is in the middle of this interval from -4 to 1, and we're shading all the values between -4 and 1. So it's just to me, visually, this definitely looks like the graph to me, where the solutions are in the middle and x is in the middle of those two values.